These are the 7.2 geometry video notes. Let's start with the cumulative practice. This says name two congruent angles if side WX is congruent to side WY. So they're already marked congruent. That tells me that this is an isosceles triangle, which if you recall from when we studied triangles, isosceles triangles have two base angles that are congruent. So they are angle X and angle Y. So angle X is congruent to angle Y. All right, we're going to learn about parallelograms today. So first of all, the definition of a parallelogram is that a quadrilateral four-sided figure is a parallelogram if and only if both pairs of opposite sides are parallel. So how we can show parallel is with these arrows. So I'm going to show that side PQ is parallel to side SR, and that side QR is parallel to side PS. Okay, the parallelogram opposite sides theorem says that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So that means side QP is the same length as side RS, and side QR is the same length as side PS. The parallelogram opposite angles theorem says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So angle P is congruent to angle R because they're opposite, they're crossed of each other. And angle Q is congruent to angle S because they are opposite from each other. Okay, this one sometimes throws people. The parallelogram consecutive angles theorem says if this is a parallelogram, then the consecutive angles are supplementary. Consecutive means one right after another. So for example, if you have P and we call it like X, just as an example, one of the angles next to it, either Q or S, let's call Y. So those are two consecutive angles, angle P and angle Q. So what that means is the measure of angle P plus the measure of angle Q equals 180, or whatever X is plus Y equals 180. Now keep in mind that the opposite angles are congruent. So you can see that angle Y, this angle, which is Y plus X equals 180. So Q plus R is 180, or R plus S is 180, or S plus P is 180. And just so you know, the reason why this is working actually comes from the consecutive interior angles that we learned back, I believe, in chapter 3 when we were doing parallel lines cut by a transversal. And we learned that these same side interior or consecutive interior angles were supplementary. It's exactly the same concept. Okay, and last but not least is the parallelogram diagonals theorem. If a quadrilateral is a parallelogram, then the diagonals bisect each other. So what that means is if you draw a diagonal from P to R and a diagonal from Q to S, then they bisect each other. Bisect means cut into two equal parts. So PR is cut in half, so those two parts are equal. QS is cut in half, so those two parts are equal. This middle point, since it's in the middle, I'm going to label it M for midpoint. Now note that QM, which is part of one diagonal, is not equal to the other half of PM, which is the other diagonal. So the diagonal PR is cut into two equal parts. The other diagonal QS is cut into two other equal parts. So they're two different diagonals. All right, so using those properties, we can tell that this is a parallelogram because it sees that all opposite sides are parallel. So what I know then is I know based on the parallelogram opposite sides theorem that the opposite sides are congruent. So side AB is congruent to side DC. So that means X plus 4 equals 12. So I can then say X equals 8. I subtract the 4. All right, and then based on the parallelogram opposite angles theorem, I know the opposite angles are congruent. So I know that angle A is congruent to angle C, which if they're congruent, that means their measures are equal. So that means Y equals 65. All right, if you want to watch B, I guess go ahead and pause the video and try B, and then I'll explain it in just a minute. Go ahead and pause now and attempt example 1B. Okay, so I knew that opposite sides are congruent, so side PQ is congruent to side SR, which means that PQ equals SR. So I set 20 equal to 3y minus 1, and then I'm going to add the 1 to both sides, and then I'll divide by 3, and I get y equals 7. Then I know opposite angles are congruent on parallelograms, so 2x equals 54. I divide by 2, and I get x equals 27. All right, looking at example 2. It shows this picture. It's a little hard to see, but it's up here in this area. I'm going to redraw it just so it makes it a little bit easier to see. So it is a parallelogram, and it is labeled BCDA. All right, it says, as shown, part of the extending arm of a desk lamp is a parallelogram. So that's how I know it's a parallelogram, as they told me. The angles of the parallelogram change as the lamp is raised or lowered. Find measure of angle C if angle D is 110 degrees. So angle C and angle D are not opposite, so they're not equal to each other. They're consecutive. So I'm going to use the parallelogram consecutive angles theorem, which says that consecutive angles are supplementary, meaning angle C and angle D add up and equal 180 degrees. That's what supplementary means. So angle C plus 110 degrees for angle D equals 180. So I'm going to subtract the 110, and I find out that angle C is 70 degrees. All right, over here on example B, it shows this parallelogram right here. And it says it is a parallelogram, so that's how you know. Find angle B when angle C is 135 degrees. So that angle in there is 135. So if I want B, keep in mind, B and C are not opposite, so they're not congruent. They are consecutive interior, which means they are supplementary. So angle B plus the measure of angle C equals 180 degrees. That's what supplementary means. So angle B plus 135 degrees equals 180 degrees. Now, if I subtract 135, I find out that angle B is 45 degrees. Okay, so we're doing a proof to prove that angle B is congruent to angle F. Remember, in a two-column proof, we're going to start with the given. The given is ABCD and GDEF are parallelograms. And I'm just going to use the symbol for parallelogram, and that's given. All right, let's see what they wrote down. They wrote down that angle B is congruent to angle CDA. That's this angle right here. Now these are opposite angles. So if I look back at my theorems, I see that that's parallelogram opposite angles theorem. It says that if it's a parallelogram, opposite angles are congruent. All right, now it's saying that angle EDG is congruent to angle F. That's this one, is congruent to F. That's, again, the parallelogram opposite angles theorem. I'm going to draw a little quote mark, just meaning repeat that right down there. Okay, now it wants me to use vertical angles. Remember that vertical angles are like this, when two vertical angles are congruent? So that would be these two angles right here. So I'm going to say angle CDA is congruent to angle, it was EDG. And that's because they're vertical angles. And then it wants us to use the transitive property of congruence, which basically what it's saying is if angle B is congruent to CDA and CDA is congruent to EDG, then the transitive property says angle B is congruent to EDG, but I guess I forgot one. Also, we know that EDG is congruent to F. So if I take out that, I find out that if this angle is congruent to this one's congruent to this one, and this one's congruent to F, then that means B is congruent to F. And that's the transitive property of congruence, and it also makes sense because we always end with what we're trying to prove. Okay, so they're telling us these two shapes are parallelograms, and they're asking us to prove that angle C is congruent to angle G. So first they wrote down that they are parallelograms because it was given. Now they're telling us to use vertical angles theorem. These two angles are vertical angles. So I'm going to write down that angle CDA is congruent to angle GDE because those two are vertical. Now they're asking us to use consecutive angles theorem. Consecutive angles theorem said that in a parallelogram, any two consecutive angles are supplementary. So if I am trying to prove with C right here and G, that's what I'm going for, I probably want to use those two angles. So first I'm going to say that these two angles are supplementary. So I'm going to say that angle C and angle CDA are supplementary because that's what the consecutive angles theorem says. It says if it is a parallelogram, consecutive angles are supplementary. Now I'm going to talk about these two angles and say they are supplementary. So I'm going to say angle GDE and angle G are supplementary. So how I get from there to the end is I do the congruent supplements theorem. You haven't seen that one for a little bit. What the congruent supplements theorem says is if two angles are congruent to the same angle, then those first two angles are congruent to each other. So because angle C is congruent to CDA and G is congruent to GDE, and those two are congruent to each other, it means C and G are congruent. All right, we're just going to do 4A on this one. So let's just go ahead real quick and graph this. I'm going to pause the video and graph points L, M, N, and O, and I'm going to label them. Okay, so it wants me to find where the diagonals intersect. Now remember, these are a parallelogram. First of all, they told us they are a parallelogram. They use that symbol. So I know that the diagonals are going to bisect each other. So that means the diagonals are going to cut each other into two equal parts. Now I'm pretty confident it's right here, but how I can know for sure is I can find the midpoint of one of the diagonals. So let's say the midpoint of OM. So O is 0, 0, and M is 7, 4. And the midpoint formula is where you add the x's and divide by 2 and add the y's and divide by 2. So 0 plus 7 is 7. 7 divided by 2 is 3.5. 0 plus 4 is 4. 4 divided by 2 is 2. So I'm glad I checked this because the midpoint is actually at the point 3.52, which why it looks off maybe because I didn't use a ruler to draw on my diagonal, so I wasn't very exact. So the midpoint is this point. And I can complete that using the theorem that says diagonals bisect each other. So I'm going to pause the video real quick on this problem. It wants me to go ahead and graph the W, X, and Z. So I'm going to pause it and graph those and label them and come back and finish this up. Okay, so I have this on here, and to find the missing vertex, the missing corner, I know that opposite sides are parallel. So like this side WZ goes down 1, and then it goes over 5. So if I mimic that from X, if I go down 1 over 1, 2, 3, 4, 5, I'm going to be right here. This is the point 2, 1, and that's the point for Y. And I just use the fact that opposite sides are parallel.